Yo, welcome back. All right, here we go. Got a doozy of a question here. So it says, let f be the function defined by this, where a, b, and c are just constants. Looks again to be a rational function, polynomial divided by a polynomial. The only difference between this and the last question is now we have these mysterious values, a, b, and c in here that we're probably going to have to figure out. So the graph of f has a vertical asymptote at x equals 2. That should tell you that if you plug 2 into this function, right, you're going to get not 0 over 0, or I'll write number over 0. Also tells you that you have a point discontinuity at x equals -1, which is going to tell us that if we plug -1 into this function, we get 0 over 0. So now it says show that a is -3 and b is -6. So basically, let's figure out what a and b are. Now, what was the common thread with the given information? Because of these areas where the function is not continuous, right? They are values of x that make both bottoms 0. So it probably would make sense to kind of start there, right? So in other words, let me set this equal to 0, but at the same time plugging these values in. So in other words, when x is 2, right, if I have 3x squared plus ax plus b equals 0, well, when x is 2, that's going to equal 0. That's what this says, at this vertical asymptote nonsense. So I'm going to do 3 times 2 squared plus a times 2 plus b equals 0. 2 squared 4 times 3 is 12. So I'm going to get 2a plus b and then 12 plus that, but I'm going to subtract the 12 over and write that. So notice using this first bit of information, it tells me the denominator must be 0 when I plug 2 in, and that gives me one equation with a and b in it. Now that's not enough to solve for a and b. I'm going to need another equation. Well, lucky for us, they also gave us this information, which is when you plug -1 into that denominator, you're also going to get 0 because there's a point discontinuity there. So when I do this, this is -a, this is plus b, and then this would be, let's see, -1 squared 1 times 3 is 3. Move it over, you get -3. You now have a system of equations with two unknowns. So we should know how to solve these. This is like 8th grade math now, right? What I would do, and there's a billion ways to do it. You can do method of elimination. You can do method of substitution. I am going to go ahead and I'm going to take this equation. I'm just going to rewrite it. 2a plus b equals -12. Then I'm going to take this equation and I'm going to multiply everyone by 2. So I get -2a plus 2b equals -6. And now I'm going to add them. So I'm doing method of elimination. So the a's are going to sum to 0. I get 3b equals -18. 18 divided by 3 is 6. So I get b equals -6. Now that I know b, I can chuck that into either equation. So a plus -6 equals -3. Add the 6 over. -a equals 3. Divide by -1, multiply by -1. A equals -3. So using this fact, I was able to show that, you know what, A and B are the values, in fact, that they told me. All right. So now what about find the value of C? Well, now remember, okay, because there's a point discontinuity. When I say point discontinuity, I'm talking about this type of situation, a hole, right? That means when you plug a value in this case, -1, you're specifically going to get 0 over 0. So that means that if I looked at this expression, x squared plus cx, right, that's going to equal 0 when I chuck -1 in. All right, so I would do -1 squared plus c times -1. So that's going to be 1, right? So 1 minus c equals 0. So c is going to equal 1. So that actually enables me to find the value of c. So let me rewrite what I have here. So I now have f of x, and it's x squared plus cx, so plus 1x. Maybe I'll just emphasize the 1, all over 3x squared, and then the a was -6, so -6x, and then, oop, I screwed that up. A wasn't -6, that's what my b was. So let me just do a little eraser job here. Go back to my pen. All right, so it's going to be a is -3, so -3x, and then b -6. So this is what this would boil down to. Now, interesting enough, The work's kind of already done and this isn't needed, but let's just do it. Let me factor this. Let me pull out an x here, and I'm going to get x plus 1. And let me go ahead and pull out a GCF first. So that's going to be x squared minus x minus 2. And then I can factor that a little bit more. Hopefully I have enough room here into 3 times x minus 2, x plus 1. Oh, look at that, right? Remember, when you cross out those like factors, that tells me I'm going to have a whole. So this function will simplify to x over 3 times x minus 2. Just kind of show you how it plays out. Okay, that wasn't necessary. I just wanted to show you how it played out. So now it says to make the function f continuous at x equals -1, what must this functional value be? Well, remember, if we're going to talk about continuity, that means the limit of f of x as x goes to -1, we want that to equal f of -1. So I got to do the limit of f of x as x goes to -1. Now, if I directly substitute, initially I'm going to get 0 over 0, right? If I chuck that in here. The thing to have done would have been to factor this function and simplify, which I did here. All right, and so now what I can do is I can say that this is going to equal the limit of, and I'll write my simplified function, x over 3 times x minus 2, as x goes to -1, I'm going to chuck -1 in here. And if I do that, I'm going to get -1 over -1 minus 2. That's minus 3. 3 times minus 3 is minus 9. At the end of the day, I'm going to get 1/9 for this limit. Well, obviously, if the function is going to be continuous, then the functional value must equal 1/9. So that would tell me that I'd have to make f of -1 1/9. All right, so now let's try and drive this home a little bit with Desmos. So I went ahead and I plugged in my values for A, B, and C, and I get this graph right here. Now remember, it said there's a vertical asymptote of 2. Does it seem like there is? It certainly does, right? And also remember that there was a hole at -1. Again, Desmos doesn't show us, but if I click on it, I see it. If I want to force the issue, I can have us plot that hole like that. And then what did we do in that second part of the question? We found the value that plugged in the hole, right? And that value we said was 1/9. So take a look. If I plot -1 1/9, right? Bam, it fills it in, okay? And that's kind of what we did in that second part of the question. All right, so great little question. Play that video back 8 billion times until it makes sense. See you soon.